Okay, recording started. So today we're going to talk about Git, and we will see how Git works and how to use it. Furthermore, this is just a simple introduction to Git. By the way, this is not a I will not make you a masters of Git or anything like that. It is just something that you're gonna need as a tool, so you could like start working at the faculty with a little bit more ease. So, for example, while you're working on your with other subjects and working with other colleagues on the same projects, if you need help from someone or something like that, you just simply don't send source code anymore by a zip file or anything, but you will actually like commit the code on GitHub using Git, and people will just simply be invited to your repository, will modify your code, commit it in GitHub, and then you pull out the changes. We're gonna see all that throughout this lesson and the next one. This one is more like we are actually getting out of the Dennis's track. So Professor Dennis is actually working with you in classes on Windows Forms and other features of C#, like still teaching you the C# bit. And here we're gonna actually just deviate just a little bit outside and cover a bit of Git here. So once we get back, we will actually get up to speed with what Dennis has covered. Okay. So that's one thing. The second thing here you see on my screen here, like you see my browser, I have an interesting extension called All My Posh, which is making my console looks like this. I'm using Windows Terminal, and Windows Terminal gives me the ability like to configure things. It's actually like I think you're gonna have the same thing with PowerShell. So let me actually check here. I think PowerShell will work the same way. So there you go. But I didn't configure my PowerShell, so that's why it looks like this. So if you would like to configure your Windows Terminal to be like mine, you can feel free to go in this, and I'll actually paste the link here. And I will, and obviously you take Windows right away, not the Linux one. So hang on, let me. Can I delete this? Yes, I can. Perfect. So this is the one. If you are on Windows, if you are on Linux or Mac, then you do your pick. So follow the instructions, and you can actually do this. Also, there is a video, YouTube video by I think Mike Hanselman, I think his name was. Hang on. Yeah, he has like a 50-minute tutorial and another 12-minute tutorial. So let me actually like share this as well with you. So this is how to set it up from scratch, which is great. Wordy and detailed, so you can actually follow the guy if you want to. So you can actually have something similar to mine. Mine is different than his. Configure it based on my preferences. Okay, so let's talk a little bit about Git first. So Git is a source version control. It doesn't equal GitHub. So GitHub is the server, okay? Or like let's say it's a hub, basically speaking, where you can host your repositories online, right? And then you can synchronize them with the team. It's a distributed source version control system, meaning that anybody who has a code, like anybody who has a project, they have the full history of the project ever since started, okay? And everybody has a copy of that history on their machines. So just let me give you a little bit of history here. So before Git actually came to be, there was actually Subversion, and there was Mercurial, and Bitkeeper, and maybe other ones, I don't know. Subversion is a centralized source version control, and you don't have and you don't have the full source code of the whole project or the full history in your machine. In fact, they have centralized. Everything is centralized. That means that if a meteor hits the server, that's it. That's it. The whole source code history is gone. Maybe the whole thing is gone. The Mercurial, I think it was distributed, but it was a little bit easier to use. I think I remember clearly, like a Subversion, I couldn't use it with my friends. Somehow, like back then, we just probably we lacked the knowledge and how to manage this, because it really required a little bit of effort. Mercurial was a little bit easy to use, but still we had some interesting difficulties with it. Bitkeeper, I never heard of, honestly, until Linus Torvalds was talking about it. Linus Torvalds is actually the one who made Git. And the funny thing here is he was using he made Git in order to work on the Linux kernel when he's working in a team with people. Like he commits the code and he would like to work with other people. In the past, he said he was like using something which is called tarballs. Tarballs is like, imagine that you are zipping your project in one file, like just zip your project and then you send it to other people. So this is what he did literally. He was like zipping the project, sending to other people, and and people send him back the zip files with the modified code and so on and so forth. And the funny thing here is he doesn't like to talk with people much. He doesn't like to interact too much with people. So he made that Git. But what made him even more moving, like to make Git, he was actually using Bitkeeper at the past. And Bitkeeper is quite similar to Git in terms of the philosophy of it, I think, which is how distributed it is and so on and so forth. So Linus Torvalds, he was actually starting to modify Bitkeeper according to his liking, because I think it was open source back then, but Bitkeeper people didn't like the idea that he was tampering and doing a lot of other things in the code. So they told him to stop because licensing issues and other things. So he actually said, okay, screw you all, I'm gonna make my own. And in, like he said, actually in 15 days he made Git. So he just sit down 15 days, you got Git out, right? So he made the first version of Git, and then he started to use it for the Linux kernel internally, and it was just only used for that. And then later on, I think he distributed it. He actually shared it with the rest of the world, and said like, okay, here you go, you can use Git as well. And Git is open source, by the way. There is actually a resource for learning Git. So if you look at git.com. Oh, wait, I think, let me write Git then. Probably I made a mistake. Git.scm source control. Hang on, so this is the one. So here's the main website. It has all the full documentation. So you have like, if you look at the documentation, oh, by the way, this is the latest version you download. So if you download the version for Windows or whatever, for Mac and Linux, it's all there. The documentation they have even the book, which is actually free to read online. So this Pro Git book, the latest version, there you go, 2014. You can download this PDF, and you can read the whole thing. So you can actually like learn more about it if you need the documentation. There are videos. There are other references, right, for like what are the most common commands that you can use in Git. So practically speaking, Git is just a source version control, just keeps track of the content of your files. Okay, you download Git, you install it from the website which I've shown you right now. So if you download Git from here, and you install it. Once you are done with installing it, it actually will give you. Let me minimize this. If you installed Git Bash and Git GUI, you're gonna get those in the context menu right here, like I do, right? So I'm just gonna go ahead, create a new folder. I'm gonna call this learning Git, okay? And in fact, I'm gonna navigate to this one. So I'm gonna right-click Windows Terminal here, and right now I'm actually in learning Git. Okay, so when you are actually working with Git, there's one more thing you need to know about before I carry on with the demo here. So you would like to, for example, like having a team of people working with you, and you want to you know, like not to, like you would like to share the source code with other people. Like for example, you got stuck in a homework and you would like your friend to help you out. You just simply commit it up, right? And then your friend pulls it out, and then they start working with it. And Git actually tracks like your files, so tracks tracks content, and it has to pass through several stages before it actually gets pushed on the internet, or pushed to the repository at least. The first one is the working area. So you're actually in something which is called working area. Here, when you create a new Visual Studio project or you create a new file, you actually start, you know, doing your own thing. You do your own stuff, and you are, you know, happily working in your own environment. Now, in order for you to push your changes somewhere, like this is, so you have here something which is called staging. Staging. And then you have here repository. Repository is the endpoint. It's like where you, this is like the repository. Oh boy, a little bit of mouse art. So there you go. You're working here. Once you are done, you would like to push this to your repository. You have to first migrate it to staging. And then from staging, you go to repository. And for repository, you can go actually online. So you can actually push it to the server later on. Okay, so this goes to the server later. But basically, your repository is the thing which you keep is like the final destination of your files, which you have actually created. Okay. Now, the reason there are 3 stages is because if you are working on something, and you would like, for example, let's say you created something temporary here. You would like to erase it, right? You don't want Git to keep track of it, right? The moment is actually in staging. Right now, it's been officially been tracked by Git. And the moment it changes later on in the future, Git will say, hey, this has changed. You need to keep up the changes, okay? So that's why you have the working area where you can delete and move and do all whatever you would like to do. And then whenever everything has been solidified, you just simply stage it, all right? And once you track it or stage it, right now you actually say, okay, I'm actually done. Everything is beautiful and fine. Right now we're gonna push it or commit it to the repository. So this is how it's actually working. Now you can actually go from here to here. You can actually undo, and also you can undo from here to here. Okay, so it is actually possible. Today's lesson, we're gonna be discussing how Git works and how to do some very, you know, like very primitive way of, or basic way of dealing with with Git repositories by just simply going in one line almost. Maybe we'll undo here once, just for the sake of the demo. And then the next time we're going to be seeing the undoing this. Also, we're going to be actually trying to work in a team and see how can we resolve conflicts, because it can happen that 2 people working on the same file, right? And then the Git repository will say, okay, I'm trying to merge those 2 files because you have only one file in there, and there are two people change the same file. So we need to pick up how the changes will happen, how we're going to merge those changes, right? So we're going to talk about that, and we're going to talk about merging branching strategies and such. Okay, so for the time being, we're going to be just discussing the simple manner of using Git. Okay, so the first thing which you would like to do is keeping that mental model in mind. And also, I'm just going to keep it right here, like on the side, until we need it. So I'm actually in this folder called Learning Git, and here I'm going to have in order for me to initialize a repository, all what I need to do is just simply say git init, right? And it will initialize immediately an empty repository at that location. Okay. Now here's the interesting bit. You could say git init and then the name of the folder, and it will create the folder for you. So for example, my sub project, for example, right? And when I do that, it actually will create for me a folder. Within that folder, so a folder within that folder with a .git file in it, .git folder in it, okay? But let's actually erase that one. I don't need this. So let me just delete that. And I'll get back ls. Okay, so clear. Right. So, as you've seen, actually, this guy has changed even because the plugin of how all my Posh is actually working. So that's why it immediately told me like we have some changes in there. But we're gonna see that in a second. It's actually a very good even learning tool, if you will. Now, if I would like to create a file, so I can actually say notepad readme.md, which is actually quite famous file in GitHub. So if you actually go in an open source, like let's see, .NET Framework, .NET Core or .NET Framework, or hang on, Core, GitHub maybe. So this README part, you see this readme.md, it's actually the file. There it is. Okay, and it's just a simple text file. If you actually look at the raw form of it, this is the raw form of it. I'm just trying to zoom out. So this is the raw form of it, just a simple text file that GitHub interprets in order to give you a very interesting README kind of look. Okay, so I'm just creating one here and nothing more. So I'm going to hit enter. And right here, I'm just going to have this is my README file, or learning Git here with README file, let's say. Okay, so I'm going to save this. I'm going to close this. And I will actually hit, then I'm just going to like say Git Status. And when I say Git Status, it says that you have some untracked files. Okay, now if you can see here, actually I have here like one more thing going on with the plugin. It says that right now I have one file has been added to my repository, right? So it's actually like showing right here. Now there's one more thing I can show you, which is going to be make it a little bit more fun, I think. I will launch another Windows terminal. I'm just going to put it side by side here. Actually, hang on. Windows terminal from here. I'm going to just put it side by side here. Okay. Now the .git folder is in fact it's just a hidden folder, and do not delete it in case it gets bigger, because this is your whole repository, right? So if I just try to push it right there. Yeah, okay, fine. I will just keep it here. And then here I'm gonna just simply say cd.git, and if I say tree, you see this is like you're giving me the directory listing, and if I say tree/f, it gives me the directory listing with the files, right? So this is how Git folder looks like even before I added any files. Okay, so let me clear this, and I will actually write a small shell script for you, which is what it will do is just will keep refreshing my window here with the following command. So I'm just simply going to write tree/f. Maybe I have to clear first, so clear, and then tree/f, and then and I will need actually just to say that this is actually .git. Please display me the tree of the Git folder. So maybe I'll take that and I'll just simply cd backwards, and then copy paste that in. So I'm gonna have like a semicolon, start, sleep, and seconds 1. So please refresh every second. And I think this is pretty much it. So let's see. Okay, so right now it's actually refreshing, right? You see, every second it just draws a new one, right? So so that's it. Now, before I actually get into this, Git actually tracks 4 things. It tracks a couple of things. The most important ones of them, like 4 of them, it tracks something which is called a blob. And a blob is binary large object. That's what it stands for. It's like whatever file you have, it tracks its content. You have a blob as well in SQL, by the way. So blob is an actual data type as well in SQL, just to let you know. So if you see the word blob, it means it's a binary large object in the terms of our IT, CS, or whatever developers world. Then we have, then it also tracks something which is called a tree, which tracks the location and the name of the file. It also has something which is called, it also tracks something which is called a commit. When you actually commit a file, or when you like say the file has been worked on, please do follow it, or please do track it. I mean, please do track it. I mean, the commit is, yeah, commit is just simply like pushing it to the repository records, let's say. So it tracks a commit, and it also tracks something which is called a tag. And a tag is a way that you can mark your commits just with a simple tag, like the pricing tags on the clothing, right? You just simply mark your commit with the tag just to identify a specific one, so you can refer to it later. But you will see this, I think, in production only. You will not use it right now during the classrooms or anything. Maybe you can play with it, but we're gonna basically cover how to do commits and stuff. And this is just for visualization, nothing more. So this is what actually Git keeps track of, just to be clear here. Now, if we look at this right now, we have added readme.md file, and it says there are no commits yet. I'm on the master branch, and there are untracked files. So in order for me to track the file, just simply say git, whoops. I just need to say git add readme.md, okay? And if I have several files, I don't need to write them all. I can just simply say git add and space and dot, and we're gonna see that in a minute. So if I say add, and watch what will happen in this screen. And right now, a new object appears, actually. And it says here that I have right now a file that has been added, or been tracked, but not committed yet. Okay, so let's actually commit this so you can actually see what is it all about. So I'm going to say git commit -m. -m is used to add to do a comment. So git commit -m, and I will write here initial commit, my initial commit. Okay, and I'm going to hit enter. And the moment I did that, immediately this has changed as well, right? So what the heck are these anyway, right? So let's see. So if you would like to, we can first of all clear this. Right now it says that I actually like all the green, the master branch has been synchronized. Right now there are nothing to commit anymore. If you would like to, you can say git status. You can see I'm on the master branch and it says nothing to commit. Working tree is clean. There are something which is called work trees, by the way, which is your working area, but it's called working trees because you can do other interesting things which we will not discuss in this course. I would advise you that you explore it. You can say git show, and then this is a SHA. This is a SHA-1 by the way, that it is actually used not for security. So the hashing algorithm is not a security measure. It's a measure that to identify unique files or unique commits and unique blobs and so on and so forth. Nothing more. It's just used to ID, not to secure. So just to be clear here. For those who are interested in security, I mean. B78567. So I just simply grab the initial SHA, B78567, right? Just the initial bit. I don't need to write the whole thing. And I will just hit enter. And right now this, I just simply said, give me the content of this guy. What is this guy? And what you see here, this is actually a commit with this SHA, which you can see here, it's exactly the same, right? And it says who's the author, and it says which day it has been, what is actually the comment, right? What are the diffs, what happened actually before you did comment, what files has been added, right? And even the content of the file. So this is the whole commit object, which I mentioned here, right? It keeps track of commit, right? Let's see the other one. So I'm just gonna clear here. I'm saying git show C6 and then 9F12B. And right now it says this is a tree object, and it just simply points to readme.md. That means that the content or the content of the file is separate from the name of the file. So if you rename the file, you just simply change the tree, but you don't change the content of the file, right? So let's see the next one. Git show CAAF903. And as you can see here, it prints out the content, which proves the point. Like Git is actually tracking only the contents of the file. Now here actually is the fun question. What happens if the file gets big, right? So our source codes are not like that tiny. It's like not one single line. It's it's larger and larger. And Git actually can handle that. Git actually can handle up to 100 megabyte file. Afterwards, Git gets very, very slow and it cannot handle it. And that's why you need something which is called Git Lfs, which is Git for large file systems or file storage. Git large file storage. This you will not work with unless you are working with really, really big files. Like, for example, in game dev, let's say I'm working with files that are 200 megabytes, 300 megabytes, 1 gigabyte files. And if you're working with such big files, like one PSD file is, let's say, I don't know, 100 or 200 megabytes, or a 3D model that is even more than that. When you are actually committing this, Git will have to check the content of that file. And in order for you to work with it correctly, you work with Git Lfs. So unless you are working with big files, you will actually use this. Otherwise, you will never be using this, I think. At least if you are doing full stack development, I cannot remember seeing someone using Git Lfs, to be honest. Even mobile apps, also haven't seen it. But yeah, just for you to know, if you have a Git repository that works with the big files, yeah, like one file which is like really heavy, then you just use Git Lfs. Actually, in the next semester, when we work with graphics and Unity, you will see that that some people actually get into the mistake of committing big files, which they shouldn't, at least because student projects are kind of tiny. But some of the students actually had problems with big files, so then we had to use Git Lfs back then. But we will see that later, I think. Okay, so that covers this part of the story. So right now you know how at least Git works. Just to summarize, I will actually stop looking at this one right now. For now, I'm just gonna hit Control-C to stop this from refreshing. So to summarize what has been done so far, we have been trying to add a file. So for example, when we say notepad myprogram.cs, and then we write in using system and then namespace program, and then we have a static void main. Then you have a console.write line hello Git. Right, so usually like a simple C# program. What we have done was you have like right now when you say Git status, you get immediately the untracked files. So you are actually in this area. In this area, right? And then to summarize, you said git add all the files which you would like to include. And then you say git status just to be checking what's happening. And then you see that actually the Git has been tracking this file. And then we say git commit, you say -m my new feature, right? And then you hit enter. And right now your program has been committed to the repository. Right now, you went from here after the git add, so you go to here by git add. This is how you get here in the staging. And right now, when we said git commit, you actually go to the repository. So git commit. Whatever these letters are right now. So there you go, git commit. Okay. All right, so one more thing. If I write in git k is a GUI tool provided by Git that you can actually visualize what is your Git repository looks like right now. Okay. Yes, Harisa.
I just have one question about the extension. Is it gonna work on any terminal that we set it up on, or is it just gonna work with the Windows PowerShell?
All my Posh actually is cross-platform. I don't think it works. No, it doesn't work with the command prompt. It works with PowerShell only.
Okay, thank you.
Okay. No problems. Sorry, I didn't notice the hand was raising. I don't know how long you were waiting for the question. You just looked and I noticed.
No problem. It was just a couple minutes.
Okay. All right. So you can see here right now my history. You see the initial commit, then the masters, like the new feature is actually here at the master branch, and you can see actually the details of my commit here, right? So this is the first commit with the Git file and its MD file with its content, and then you get another commit detail with all my changes right here, and even tells you here's the stuff which has changed, and you can see the tree which shows you all the files that has been like in the current repository, right? So this shows you the patch, what has been patched or what has been changed, and this is the tree. So there's the old version, new version only, and the diff, which is the difference. But again, we will discuss that probably later. Okay, so that's one thing. I think there was a way as well. I just cannot remember anymore right now. To visualize this in console. So I think Git 3 was it? Right. Git Log Graph, I think. There we go. So this is a graph showing my commits with like in a visual way, but right now I have just one commit and the other commit, and that's it. So it's just one single line. Now you might be asking yourself, what the heck is head and what the heck is master, right? Which brings us to the next point. If you actually look at, I'm actually using this as a visualization right now. So, okay, how about this? Before I actually carry on, I will actually give you just a 10 minutes break before I actually dive deep because I'm gonna need to talk about branches and how we merge and do stuff in the visualization part. So let's take a 10-minute break and then we'll get back with a little bit fresher minds. Try to grab some sugar or coffee or water, whatever gets you going. After the break, we're gonna talk then. All right. Honestly, I just didn't follow exactly the time. Probably 10 minutes has passed already. It did. Or 5 minutes passed. All right, I'm gonna actually start regardless then, because I honestly lost track of time. So let's carry on regarding the branching bit. So currently, if you look at Git right now, like right now, our Git repository has something like this. This is a learning tool, by the way. It's just a visualization to learn how you are actually working with Git right now. Whenever you do something, just it reflects here. So if I say git commit -m my new feature, immediately just generates a commit object, right? And by the way, the Git is actually based off of the inode data structure. I think it's called inode. Hang on. It's actually the data structure of the operating, like the file system of Linux, by the way, as far as I remember, Unix file system. So this is the data structure, and Git is based off of that or similar to that. Okay, you can actually read more about this later. So you're gonna get like some sort of nodes and trees, if you will, of the more you work actually in your repository. But the interesting part here is if you look carefully, every commit points backwards. So if I actually just simply say git commit without even a comment, so git commit, another git commit, another git commit, which is actually makes a good point. You never point to the future, right? Because the future never happened. You always point backwards. You always point to the last commit that has happened before you, right? And the interesting part here is that you can actually move as well backwards in time. So you can go back in time, and then you can go back to the future, or to the present where you have been. So for example, if you have done something and has been erased, let's say, and you would like to get it back, you can just simply go back in time, get that thing, and go back again to where you were, right? Now, it happens a lot of time that right now, for instance, we have committed a file, right? We have made our project. We have created a new feature, which is our program.cs, right? And then somebody comes in and he says, okay, can you please work on a new feature? But please do not commit it to the master branch, because the master branch is where we give our customers or our users, we give them their, we serve them the build. When we make a build from that branch, we give them their product which they are using, and you would like to say, for example, I would like to change this to something else, but I don't want this happens to be here. I would like to happen somewhere else outside of that branch, right? So you don't pollute that code, let's say. So we tend to do branching, right? If you and your friend are working on the same project and you don't want to work on the same file at the same time, what you can do is, like, okay, you're going to work on the same file at the same time, but what I want to say is each one of you can work in their own track without polluting the main track. So you grab a branch and you call it the feature 1, and your friend is going to make another feature. Both of you are working on 2 features, and your friend will do feature 2, let's say. And then later on in time, you're going to actually merge or rebase, and we're going to talk about merging versus rebasing in the next lesson. But then later on, you merge your changes back, and then you get the whole project, right? So if you are working on your desktop application or mobile app, so one of you is actually working on saving the files or saving to the database, and the other one is working on UI, for example, right? So you need to merge those changes back to make a whole product so you can ship it to users and customers. So in order to do that, I'm gonna actually have, I'm gonna write in order to branch, you just simply say git checkout -b. It is actually a shortcut for two commands right now, which is, I forgot what was the name of command for creating a branch, and then you have a checkout, that name of the branch, but I'll write it all in one line. So git checkout, checkout -b, and then the name of the branch, which is going to be feature 1, let's say. I'm going to hit enter.
You have a typo.
Aha, indeed. Checkout, there you go. All right, now I switched to a new branch, and as you can see here, even my thingy is actually having has changed. Right now I'm saying I'm on feature 1 branch, not on master branch anymore. So if I say git branch, you see I have, it gives me the list of branches which I have. And it highlights for me which branch I am on, right? So if I would like to return back to the master branch, I just simply say git checkout master. And right now I switch to the master branch. And if I say git branch, I'm on the master branch, right? So let me clear this. And let me say git checkout feature 1, right? And right now I'm on feature 1. And let's say I'm actually working right now on my new feature. So I'm just going to say notepad program. Was it program.cs or hang on? What was inside there? I have my program.cs. I'm just going to say, oh, by the way, this is also another add-on that converts all my file types to icons. I forgot the name of it. I think I think the same guy, which I showed you their YouTube channel, he's having a page describing how to do that. I just forgot the name of the add-on right now. So git, actually not git, notepad, let's say I'm gonna make a new file, which is gonna be my new feature.cs. And just for the sake of the argument, this is gonna be here goes my new feature, right? And right now your code goes here, okay? So just not to type on a full C# code right now. So that's one, right? And then if I say git status, it says that I have one file that has been added and has been untracked. And if you see it, it's actually right there, right? So I'm just going to say git add dot. Right now it has been added. If you look at it, git status, it's already there. I can just simply say git commit -m my new feature added, right? And right now I have committed my new feature, right? Actually, if you would like to, right now you can see that thing become huge, actually. So, hang on. There you go. That thing became big. Right now it has a lot of other things. And if you look at the heads, actually, it says feature 1 and master, right? So we have both of them. In fact, let's see these two things before I carry on with that. Like it's just a sidetrack, just to keep track of these two things at the same time. Oh, by the way, before any of this, I actually did some, let me just undo. And undo is only for this learning tool, by the way. Okay, so undo is working only in this learning tool. It's not a Git command. I think, so we had an initial commit with readme.md, and then we did a commit to a master, as far as I remember, with the new feature or the new program. And right now we said we created a branch, right? So we said git checkout -b new feature, I think, or what was it called? Feature 1, sorry. So feature 1. And this is what was happening, by the way. And then later on, I created a file and then I added it, which was my program, right? This new feature .cs, I think. And then I just simply said git commit, right? With -m my new feature, whatever it was. And right now, my master is actually ahead. sorry, my feature 1 is ahead of master. It's just forward right now in time. Okay, so let's get back here. And let's talk about this ones though too as well. So these guys are surely, I mean, if I say git show 015ed, this is the commit of my new feature which has been added right now, right? So this is actually good. So Git is actually keeping track of this. But this is also interesting. So this, hang on. So this is, wait. This is a commit object, right? It's a commit object. It just where the head is pointing, feature 1, and this is my new feature added, right? So this is like with the new feature.cs stuff. Here goes my code, you see? Now here's the interesting stuff. What is actually inside this one then, right? That's a very interesting question. So I say git show refs, can I say slash git slash refs slash heads slash feature 1. Yeah. Pretty. Hang on, probably not. This is not it. Sorry. Can I say cat? Oh, there we go. I wanted actually to open the file content. Sorry, I just made a mistake here. You see this? It is the same as this. 015ed, 015ed. This is the feature 1 branch. So a branch, practically speaking, is a file holding out a hash of a commit. So basically branches are pointers to commits, and that's it. Okay, just to put it bluntly out there. Okay, so this is but this is very, very internal. By the way, you will never need to do this. I'm just describing to you things that you can have a feeling for. So Git doesn't feel like a black box for you. Okay, so this is just for you to know. Just branches are simple pointers to commits, and that's pretty much it. Nothing fancy about them. Okay, so right now our feature is looking like this. Now in real life, you will have multiple branches, right? So you can have, for example, something like git checkout. Hang on, git checkout master, then git checkout -b feature 2. Right. I should know. I shouldn't have spaces. And right now I can actually say git commit. Right now feature 2 is the same on the same level as the master. So git commit. And right now I have a different branches happening, right? So I can say git commit as well again, and this is just goes on its own, right? And of course, feature 1 can go its own as well. So feature git checkout feature 1, and right now you're at feature 1. You can say git commit, and you can keep committing to it. Actually, it happens as well in production that people even commit stuff in master while you are working on your own thing. You have things happening in parallel. Now you have to, of course, merge everything back, which is actually like, here it's easy because I don't have any files. I'm here learning stuff. I'm learning commands. So you say, if you would like to merge stuff, you say git merge, and then you call which feature you would like to merge into the current repository which you are checking out. Current branch which you are checking out. So it says like this: git merge whatever branch into me or into the current one, right? So right now it merges feature 1 into master, okay? And then I would like to take feature 2 and merge it into master as well. So git merge feature 2. And right now, if I say git commit, right now you can git commit stuff. You can actually git branch again out. So you say, for example, -b feature 3, and then you say git why did it execute, by the way? Oh, sorry, git check out -b, yeah, sorry. And then you say git commit, and right now you can actually do your own thing again. So usually like your git branches will just go up, like it will just grow and shrink, grow and shrink, grow and shrink, and so on and so forth. So, and by the way, let's say that this has been done, like you are working like this, and this is happening for a year, let's say. This year of progress is being kept, by the way. It doesn't go anywhere. Git is actually keeping this years and years of work. And what will happen is whenever you are checking out the code from the server, you check out the code from the server with all of its changes, with all of its history, with everybody involved. So if you have 50 people before you were working on the project and they left, you will see their 50 commits and histories, and not 50, even more, all of the 50 people histories and commits and all these stuff are going to be present in the repository. You're just going to simply check out that commit or check out that repository, and you will go, or no, sorry, check out the commit or the branches, and you will see what they were doing back then. And this is actually very cool. Okay, so this is regarding like the branching and stuff. We're going to talk about branching strategies later. I'm just simply introducing you to how Git works. And this is like the mental model that you could have in your head when you are working with Git, more or less. Now that we have feature 1, now feature 1 has this my new program.cs. So meaning that if I actually can I do this? Oh, yeah, I can, but it's not in the folder. Hang on. Minimize this. Where's my learning Git? So currently this is my files right now here, okay? So if I actually go ahead and say git checkout master right now, I switch to the master branch. If I hit ls, it's actually gone. Can somebody tell me why? That new feature was here, but right now my master, when I switch to master, it's gone. Okay, for those who are confused, if I actually say check out feature 1, it's there. It's gone. Well, people. Oh, wait, you hear me?
Maybe because we didn't commit it.
No, actually, the file is in another branch. The file is just on another branch. It has been committed. It's just on another branch, which tells you a very important message. The file, there you go. Somebody written this. So not on the same branch. If you are, I just got the notification right now. So if the file, so that's why actually when you are working on different branches, it's actually much safer, right? You don't pollute other people's code or don't pollute the main stuff. So if you happen to make some mistakes, you will not actually pollute the source code or the code base of the project. You will just simply spoiled up the branch which you are working with, and you can just simply obliterate it, delete it, or whatever you want without harming anything in the code, right? So the interesting part here is you can right now check out any source code from any repository on the internet, and on GitHub at least, and then you can just simply like modify, do your own modifications and stuff. Nothing will happen to the main source code on the the main source code which you checked out from, right? So for example, right now, just a small exercise. If we look at Dennis's source code right now, github.com/ I think I cannot remember really his GitHub/ not this, probably this then with a dash.
I pasted the link in the chat.
Oh, there it is. Thanks. So yeah, it's a hyphen actually. So there you go. So Dennis actually has multiple repositories, and if we look at it, I think this is the one which concerns us. So I can actually like go ahead, and we will work on this next time. So I just copied the HTTPS link, and I will go here, cd dot, and then in my desktop, I'm going to create a new folder. I'm going to call this mkdir testing checkout, whatever you call it, or testing remote repo. And then I'm just going to say clear. And then you can say git checkout, and then the whole thing, or git clone, sorry. So right now I just simply cloned the whole repository. Right now if I say ls, I have the C# programming, right? So I say cd this, and right now I'm on the main branch. In his case right now he named it main, not master. And if I say git branch, I can see he has this main branch, and if I say git k, right now I can see his history, right? And I can see actually all the commits and the changes he made for every file he created, for every commit, right? And right now I can actually modify things. I could just simply say, okay, let's see, hang on. What was the name of that folder? Testing remote repo. And there we go. So I can go ahead, open that. I could just simply grab Windows Forms. And let's say I'm just gonna modify the source code a bit. So I can say, okay, I don't need any comments. Save. And then if I look at my Git repository right now, let me close this. Right now, if I say Git Status, right now it says, hey, you modified this, right? I can just simply say git add dot, oh, for heaven's sake, git add dot, and then Git Status. Right now it says that my stuff is being modified. Let's say I actually have a problem with this. Let's say I actually don't want to, I would like to untrack this for any reason. Let's say I made a mistake and say like, hey, I don't want this to be tracked today. Forget it, this will be erased, let's say. So just simply call it git reset. And it will unstage the stuff. So we said that Git is having from the working to staging. And right now what I said, unstage, just go it from staging to working space again. So right now it's not being tracked anymore. So if you go to Git Status, right now it should be marked in red. Okay. So right now if I say git add dot, and then I say git commit -m, removed comment from code, Git status, and right now everything is clean. If I say git k, right now my main branch is ahead of the remote branch on the internet. We're going to discuss this again later. And right now I can, I don't know if I have the, let's see what's going to happen if I, hang on. Okay, so Control Y. I just want to see, I don't know if I have the rights to do so, but if I have the right right now, Dennis will have a surprise. Git push and great. I don't have permissions. Okay. All right. So I don't have permissions to push to his repository, to this repository at least, which is good. Otherwise, he would have had a surprise. But in any case, next lesson, we're going to actually be playing with this idea. We're going to be committing stuff to the repository, pushing things, pulling things, resolving conflicts. Both of us, like me and you guys, are going to actually change the files and change the same files, and how we're going to resolve these conflicts and how we can remerge our progress is going to be totally discussed next time. But just for you to know, so far we have covered like 3 commands, I would say, the ones which are most important. So if I actually go ahead and say cd dot and then cd dot and then I think cd testing, I think, or testing or learning. Okay, so yeah, this is me. So we actually have been, right now we have learned about Git status, which shows me the current status of the repository, Git branch, which lists me the branches in my repository and shows what branch I'm on, Git add dot, which adds all the files that has been unstaged or not staged. So it gets me the files from the working area to the staging area. All right, so this is the git add dot. Get reset gives us the stuff from the staging area, throws it back into the working area. Okay, so that's one. Then we have git reset, so we have also git checkout branch, which creates us another branch. So git checkout -b, and then the name of the branch was going to be feature 2. And right now I'm actually, it makes a branch for me called feature 2 and switches to it. So, oh yeah, there's one more thing about Git. There's, you see this is called, I think this is called porcelain command, because it does 2 things at the same time. There are 2 types of commands. There are called something which is called plumbing and porcelain commands. And plumbing means that it is like the very primitive Git commands. And once you chain them together, and that chain has, for example, a shortcut code for it, or shortcut keyword for it, it's called a porcelain command. All right. So, so yeah, this is just in case you heard about it somewhere in the books, or somewhere read about it in the books, or heard about it in the conferences. Right now you know about them. So Git, like you have these porcelain and plumbing commands. All right, so so we know about this one. Yeah, what else? Yeah, and also we have seen the visualization of Git, right? You have learned about merge, but only in this context. We didn't learn about merging in the other context. I can actually show you merge right now as well, because I think we don't have any conflicts. Git checkout master. I have to stand where I am. So if I actually say git k right now, I have feature 2, right? And if I say git k, and if I say checkout, hang on, checkout feature 1. Yeah, probably a typo. And then git k. And right now I have like all the features are in there, okay, just to show you. So feature 1 and feature 2 and the master. So let me go here back again and say git checkout master, and then I can say git merge feature 1. And right now I've actually took the changes of feature 1, pushed it into master. So if you look at git k right now, it looks like this right now, right? And if I go ahead and say git merge feature 2, feature 2 is already up to date, so it doesn't have anything. So check out feature 2. Git. And then I can just simply say notepad some other feature.cs, and I just simply create here some other feature is being implemented here. Okay, so let me close this, and right now git status, git add, git commit -m, second feature is added. Right now I can say git checkout. Actually, you can say git k to see how things look like. It looks like this right now, because I'm actually having the history of the branch itself, not the whole repository. And right now I can simply say git checkout master, git, and you can see actually git k, you're going to see that doesn't have anything to do with feature 2. And then I can just simply say git checkout or git merge feature 2. And right now, if I say git k, you can see the tree right now. So we had feature 1 and feature 2. So feature 1 have merged with master, then feature 2 has merged with master, creating this interesting tree right now, which is actually somewhat similar to this. So let me show it to you right now here in the visualizer. So I'll just simply write clear, and we created actually, so git commit, we had an initial commit in our master. Actually, yeah, and sorry, this is not, this is the first commit, the initial commit, and then we said git new feature, right? So git commit -m new feature. And then we created a branch from here, feature 1 and feature 2. So git checkout -b feature 1 without quotes. And then we committed to it, so -m f1, right? And then I said git checkout checkout master, if I know how to type master. And then I just simply made git checkout another branch, which was feature 2, and then we commit to it. We're going to call this f2, right? And then we merged back into master, right? So I said git merge, git checkout master first, because I'm merging the other repositories into my repository. Yes, Harisa.
Does it matter in which branch are we currently when we do the master, when we do the merge?
Yes, it matters. You have to stand on the branch which you are trying to merge stuff into it. So for example, I would like to say merge feature 1 inside master. So I have to stand on master. If I would like to do the opposite, merge master inside feature 1, then I have to check out feature 1, then merge inside master. Master inside feature 1.
Okay, thank you.
Okay. So Git Merge feature 1, and then Git Merge feature 2. And right now we have something similar to this. Oh yeah, probably I didn't commit something in feature 2, I think. But we got actually something similar to this, right? So if you would like to check out all the stuff that you have done so far in your code, hang on, I need to see. Oh, did I? Oh yeah, actually I turned it off. So let me go to. Hang on. Give me a minute. I need to get back to my learning Git bit, and I will open Windows Terminal again from here. So you have something which is called Git Log, which will tell you the history of all the commits that has been done so far in your project. Okay, so apparently we have done a lot of things. So we created the branch, merging the branch, and all this stuff. And each one of them is actually a commit, right? So you can actually revert to each one of those steps later on, which we're gonna discuss probably later in the next lesson. But in any case, Q, I think. Yeah, there we go. So Git log is actually quite useful in case you would like to trace back what happened when you were typing interesting things, like you make mistakes or something like that. You would like to check what happened, just Git log. Okay, I think, let me check my note here. Did I actually forget any interesting detail to cover? Yeah, we need to check out diff. Yeah, and rebase and stuff like that. Yeah, we're gonna actually talk about this in the next time when we talk about the diff, reset, hard, and rebase, and yeah, we'll discuss that probably in the next time. For this time only, I would advise you, honestly, to sit down and just go ahead, install Git, and try out this by your hand. Okay. There's also on the internet you have something like called a Git cheat sheets, and there are tons of them, man. Hey, this is educational GitHub. There you go. You have a cheat sheets where you can, like, if you forget some of the stuff, you have it here. And oh, sorry, let me just paste that for you here. This is the link to the page which I'm looking at right now. If you don't like it, feel free to find another one. There are many variations of them. And I think it's a good learning tool. All right. Do you guys have any questions so far? Here's also Atlassian cheat sheets. I just Googled it, actually. Here's a GitLab cheat sheet. Which shows you how things work and how to do things with working, the zoo of working areas like git stash and pop and add. Yeah, we're going to discuss this. Getting push or fetch and pull. Yeah, we're going to actually talk about this. We're going to talk also about Git Ignore Files because this is super important, but this is going to be kept for the next class. Yes?
Nothing. I just wanted to ask if we're going to cover the ignore, but you already said it.
Yeah. We are gonna have to cover this. It's important to cover. So yeah. All right. Okay, any, let me just then stop the recording. We actually have done, we're done with this.